Hello, my name is Ivan Scattergood. I'm the CTO and co-founder of OctaiPipe. And today I want to take you on a journey from building a deep tech platform and struggling with product market fit and discovering real-world value in an unexpected place. Along the way, we've added a lot to Flower, and it wasn't the technology that was the problem. It was narrowing the scope and figuring out how we could deliver something in a specific, to solve a specific painful, high-value problem. And I need to do, excellent. So, we started as a deep tech platform, and as you know, Federated Learning promises decentralization, privacy, and efficiency. But the reality, the reality is that it's actually hard to adopt. There's a lot of inertia. People are already using solutions and they don't want to change. And our journey goes from where we were building a generalist Edge FL platform, struggling to find product market fit, and we found a commercial niche impact. So our original goal was to enable the building of AI to keep our world safe, secure, and sustainable. And the way we thought we were going to do that was creating industrial foundation models. We'd been working in factories, developing ML solutions for those factories, and we thought we could build foundational models that would change the way that approach works. And the problem is we came across some real problems. There were some system problems like security, we had connectivity issues, the compute footprint we were trying to deploy to existing machines, and there was governance. We needed to ensure that things were secure and only the right people could do the right things. And then there was stuff that was more the data science end of the spectrum, the heterogeneity in the devices and the compute, usability for data scientists, making sure our platform would actually work, and lifecycle gaps, understanding the entire machine learning workflow and being able to do that in a distributed way. And as I say, we built a platform on top of on top of Flower, which delivered a bunch of advantages. We lowered the footprint of our client. We managed to develop a federated EDA analytics solution. We developed a whole new FL algorithm around XGBoost, which is 40% more network efficient than other benchmarks. We developed pre-trained CNN architectures. We were able to do edge labeling and a whole bunch of improvements. But after doing all that, we still struggled to sell it. And the real problem was that most data scientists aren't trained in FL and they're not comfortable with it. Enterprises fear paradigm shifts, and startups that we were trying to sell to were following the credits. So they weren't interested in using FL. And the hard truth was that the attributes of FL we were trying to promote only convey intangible benefits. So we found a niche. And what we did was we turned the problem on the head and we thought, where is federated learning not just a nice to have, but a must have? And so we looked into industries with high data sensitivity, where scaling on-prem or edge applications with FL would give us a significant advantage. And so we looked in defense, pharma, life sciences, chemicals, semiconductors. We needed something that had a lot of investment, had existing infrastructure, something that was easily measurable, and we could actually, even though we were going to federate it in the end, we wanted to offer value at a scale of 1. And what we discovered, well, what we agreed on was helping data centers. So building an ML model, a federated model that would allow us to efficiently manage the cooling of data centers. So we have used our platform to develop an application that is deployed into different data centers. We have a simulation farm where we are simulating those data centers and then running the whole application inside the data center, monitoring the temperature and humidity in that data center and controlling the set point of the fans to increase the efficiency of the cooling system. And what this allowed us to do was, one of the technical problems we had around heterogeneity meant that we were actually using it to our advantage. The fact that we were running this in loads of different data centers meant that heterogeneity would actually feed back into a model. Different data centers would have different layouts, and we would be able to generate a model that would function well across multiple data centers. And so we've managed to improve data center efficiency by 10 to 15%. And we're not stopping there. Basically, now we've got that infrastructure deployed into those data centers, we can look at, we can initially deliver this cooling optimization, but there's no reason why we can't help them with network optimization or workload optimization or various things in the future. So, in summary, there's a bunch of things we learnt. Federated learning is a systems problem, and we needed to solve the heterogeneity and security. We needed to support the full life cycle and usability, but for us to be effective, we needed to narrow the scope and focus on a very specific pain point, i.e. solve a problem, don't solve a concept, don't sell a concept.
Do we have any questions? Yes.
Cool. Thanks for the great talk. It's always good to hear these sort of war stories. The question is, what is the threat model in the data centers that you were considering? So what's the threat model? I mean, federated learning is of course interesting. That's why we're here. But I mean, why for these data centers use federated learning? So I mean, what threat are you protecting against? Because, I mean, if it's just power consumption, I guess anybody could have a microphone near the data center and figure out the power consumption. So if it's side channel attack, I mean, I don't know if it solves that threat.
It's more that. Hello? Oh yeah. It's more that. Because data centers are a secure environment, actually deploying applications into that environment is a complex task. And they just don't want to share any data. And it doesn't matter whether that data is operational data or actually useful. They just have a blanket idea that we're not sharing any data. Hello.
Thanks for the very interesting talk. So I just wanted to hear your thoughts about, because you mentioned some previous attempts to approaching different kinds of clients, and many of them didn't work. And in the end, you figure out this data center cooling application, right? So do you have an idea of why this works and some of the others didn't work?
Yeah. So we've, as a company, we've had several innovation grants. We also have existing customers that are using our platform to, but again, to deliver a specific business need. So we have a long-standing customer that works in the healthcare industry. So we're collecting data about their patients inside care homes. We're also helping a company do federated learning across the silos of different kilns where they're firing these things. And technically, again, the problem there is not a security one. It's just there's a lot of data, and moving it from one location to another is a technical challenge. So as I say, for us, it was finding something where we could, where the user of the application had a need that they didn't even know they needed federated learning to solve it.